Okay, here's part 2 of the midterm practice exam. Let's start with question number 19. It says the side length of a square is equal to 6 plus 4i. The area of the square is, well, to find the area of a square is a rectangle, so it's length times width. But in this case, the length and the width are the same thing. So really all we have to do is do 6 plus 4i times 6 plus 4i. You can do that with a box method if you want, or you can do it with the shortcut. It doesn't actually matter. Let me be a little bit neater about this. 6 plus 4i, 6 plus 4i. This is 36, 24i, 24i, and 16i squared. What you're going to need to know in order to finish this is what I squared is equal to. So I got 36 plus 48i plus 16i squared. Now I squared, you should know, I squared is equal to negative 1. So if I substitute this in, I get plus 16 times negative 1, which is the same thing as minus 16. So I can sort of ignore this whole term, and it just becomes minus 16. 36 minus 16 is 20, so my final answer would be 20 plus 48i, which is choice B. Alright, now some degrees to radians and vice versa. We've done these very recently. For this one, negative 50 degrees, we put it over 1. We got to multiply it by either pi over 180 degrees or 180 degrees over pi. You don't have to memorize those because they'll be on your reference sheet. I'm going to multiply it by pi over 180 because I want the degree signs to cancel out. So what I get now is I get negative 50 pi over 180. I can make both of these smaller by dividing by 10. So that gets me negative 5 pi over 18. That's actually the smallest it can go. Negative 5 pi over 18 is choice B. 21. Negative 11 pi over 4. I'm going to multiply this by 180 degrees over pi, because what I want to happen is the pi's to cancel out. So negative 11 times 180 over 4. I'm going to do that on my calculator, just because better safe than sorry. Times 180, and then divided by 4 is equal to negative 495 degrees, which is choice B. For 22, use the diagram provided to find the exact value of the trigonometric function sine of theta. So here's the thing, they tell you 690 degrees, and they're showing that it's like a couple spins around the circle. But you already know how to fix these. 690 is too big. If I subtract 360 from it, it's going to give me 330 degrees. So that's equal to. So this is the same thing as a 330 degree angle. Since this is 330 and this is 360, I know that this angle inside here is 30 degrees. That means that we have a 30, 60, 90 triangle. The side lengths are going to be 1. Across from the 30 is going to be 1/2. And across from the 60 is going to be rad 3 over 2. Now, the way we plot any point, we start the x-axis and we'll trace the x and then the y, right? So the x is going to be positive because it's to the right, but the y is going to be negative because it's down, and negative y is down. So they want to know what the sine of theta is. Now, which one of these is sine? 1/2 is sine. It's the height. So remember that base comes before height, b comes before h alphabetically, and cos comes before sine alphabetically because c comes before s. So that means the base is cos and the height is sine. So what they wanted was this, negative 1/2. Now, 23 slipped past me. You don't know what CSC is yet. It's cosecant. Cosecant will not be on there. But you do know how to fix this angle, negative 930. So I would take negative 930, and I would add 360, add 360, and add 360 again. Yeah, I'll just do it in a calculator, because it's probably what you're going to do anyway. Negative 930 plus 360. Still negative, so plus 360 again. Still negative, plus 360 again. 150 degrees, perfect. So this is equal to 150. So this is 180. So that means this angle in here is 30. We can create the whole triangle again from that. 60 is here. My side lengths are 1/2. And negative radical 3 over 2. So you need to know how to do all that even if you don't know what cosecant is, because that will not be on your midterm. 24. Which of the following represents the function 4 sine theta minus 1? What you need to remember about this is that this is the amplitude. That's what the 4 is. And the minus 1 is the midline. So which one of these has a midline of negative 1? Well, the line that goes through this is positive 1, so it's not A. This looks like negative 1, so it's possible. This midline, if I go to the middle between like 5 and negative 3, looks like it's about here. No, so it's not B. And this one looks like it could also be negative 1. So the real question is, which one of these goes up and down from the midline 4 units? Is it this one that goes down to negative 5 and up to 3? Or is it this one that only oscillates between 0 and negative 2? Well, I hope it's obvious. It's D. I know this because if the midline is negative 1, if I go up 4, I'm going to get 3. If I go down 4, I'm going to get negative 5. Alright, question number 25. Identify the first and last terms of the product. And just the first and the last? That's easy. The first times the first is the first. Negative 3p to the 4th. The last is the last times the last. So negative 5 times negative 8 is 40. Positive 40. And whatever goes on in between there, they don't really care because they just want this and this. And I should make sure that I label them first and last. Now, question 26, I'm definitely going to go to my loose leaf for. Question number 26 requires a diagram. Whenever you're drawing something that's geometrical in nature, you should be expecting to draw a diagram, even if it's not required for the question, because it's going to help you understand the context. So question number 26 is, what is the formula for the parabola defined by the focus of 9, 8 and a directrix of y equals 6? Okay, so what I have here is I have an x and a y axis, and I guess I could use my cheating straight line tools to make those a little better. All right, so here's my x-axis and my y-axis. I have a focus, they say, of y equals 6. It doesn't really matter if this looks accurate. The only thing that matters is that I label it, because that way it'll make sense to me. So this line is y equals 6. It says that the focus point is 9, 8. So I'm really only interested in what's going on up here. So I'm just going to zoom in on the first quadrant. A parabola, by definition, is a curve that is equidistant from the point and the line, the focus point and the directrix line. So the way we find out what the equation is we start from in between the two. We'll start around here, and I just draw a curve up and around the point. What we do then is we pick an arbitrary point on the parabola, and we call that point x comma y. Now, due to the definition of a parabola, that they're equidistant at any point, I know that this line here should be exactly equal to this line down to the line y equals 6. These should be congruent. This right here can be found with the distance formula. This one here on the right-hand side, oh, and on the midterm I'll give you the distance formula. You don't need to memorize that. This isn't a geometry class. I'm just trying to get my line straighter, and I'm being a perfectionist with a line that doesn't need to be straight. Okay, so here's the thing. This line is going to be based on y. So here's my x-axis. Here's my origin, okay? Here's my origin. So how do I plot this point xy? What I do is I start with my finger on the origin, and I move over x units, okay? Move over x units, and then I go up y units. So the thing about this is that means that this distance would be y. But I don't have all that. This is shorter. Right, this only goes from here to here. That's the line that I want. To the directrix, it's not as long as the y line. So how do I figure out what the distance is? Well, it's shorter. So shorter is made by subtraction, right? So I'm basically I'm subtracting off this section. So if I could cut this guy off somehow, I would make them the same length. Well, how long is this section? It's 6 because it's between the x-axis and y equals 6. So this line right here, the brown dotted line that I've made, is actually equal to y minus 6. Now, the distance formula between those 2 points is equal to y minus 6. So let's do it like this. Point 1 will be x comma y. Point 2 will be 9 comma 8. I'm going to use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, and that's going to be equal to y minus 6. I'll plug them in, so point 1, so that would be x1 and y1 accounted for, and now I'll plug in for point 2. 9, 8, so it's my x for point 2, that's my y for point 2. Now I'll rewrite the rest of the equation here. And don't forget the square root is equal to y minus 6. What I need to do now is I need to solve for y equals, because they want the equation, and equations say y equals. I got a y here, and I got a y here. I'm going to need to unpack this. So I'll square root both sides. The square root cancels out with the big square. Square cancels out with the big square root. What I get left with is I get left with 9 minus x squared plus 8 minus y squared is equal to y minus 6 squared. Now you can use 3 separate box methods, but what I like to do is the shortcut. So what I'm going to do is I'm going to do that. 9 squared is 81 minus 18x plus x squared. Next one. 8 squared is 64. It's going to be minus 16y plus y squared is equal to y squared minus 12y plus 36. The first thing that happens is you always get a y squared on both sides. Y squared and y squared. So let's cross them both out with subtraction. I want to get the y's by themselves, so I'm going to move this y over to join in with this y on this side of the equal sign. 16 y's are gone. I want to get these y's by themselves, though, so what I'm going to do is I'm going to try to move this 36 away from them. So minus 36. I'm going to want a little reset. So I got 81 plus 64 minus 36. A little scratch work because I don't want to open a calculator. That is 145 minus 36 is 109. So what I'm going to get is I'm going to get 109 with the numbers minus 18x plus x squared is equal to negative 12. Nope, sorry. Negative 12 plus 16 is 4. So we have 4y on the right side. Y is almost by itself. We're almost done. So divide by 4 on all the terms. And I can rewrite just a little simpler. Y is equal to 1/4 of x squared minus 9 over 2 x minus 109 over 4. And that's the equation of the parabola that fulfills those criteria. We have a whole lesson on that too, if you want to go through some of the old videos. It's called the definition of a parabola. Okay. 27. If f of x is equal to 2x plus 3 over 107, and g of x is equal to 3x plus 1 over 113, which is greater, f of 10 or g of 10? I'm not going to do this one. This is a freebie question. F of 10 means plug 10 into the f function. You could do that in a calculator. Find out what the decimal is. G of 10, plug 10 in here and solve this one. And you literally just say which one is bigger, f of 10 or g of 10. For question 28, this one's a little more interesting, not hard. They say, what's the possible function that represents this? So what we need to do is we need to make sure that it has the same zeros, the same roots. So what are the roots? The roots are x equals 1, x equals 4, and x equals 8. So here's what we're going to do. We're going to find the equation that these came from. X equals 1, x equals 4, and x equals 8. We're just doing a reverse of the t-chart. So if I minus 1, I'm going to get that x minus 1 equals 0. Boom. So x minus 1. If you're good at this, you might just see already that this is x minus 4, and this is x minus 8. And this is actually the answer. You don't need to multiply it and get it in standard form. This is perfectly acceptable. Or I guess technically the answer would be y equals. So y equals x minus 1, x minus 4, x minus 8. That would be a better answer. Okay, 29. Graph the function 3 cos theta, labeling all maxima, minima, and intercepts. Well, you guys really only do this from 0 to 360. That's all we've done, so you wouldn't have this extra space on your graph. But here's how this works. And let me actually draw a heavier line there to show that that's my ending point. 360 is here. Okay, so we're going to stop here. Here's how a cosine graph works. It has no midline on the end, right? Plus some number, right? It has none. So that means the midline is the x-axis. That's better. 3 is the amplitude. So it goes up or down 3. So what does it do? It starts at 3. At 90 degrees, it hits 0. It hits its minimum, which would be down 3, at 180. Comes back up at 270, and its maximum again at 360. So my graph would look sort of roughly like this. I'm going to just sketch it in real ugly because I'm a math teacher, not an artist. And throw some arrows in the end. And that's what cosine looks like. my maxima, my minima, and my intercepts are all clear because I put points there, so it's clear to anyone who's grading this that I know which points are on this function. You can label them with numbers if you want as well, but I think this is fine. Okay. Identify the solution set of the following system of 3 equations. I don't really feel a need to do this one because we have a lesson on it already, so instead what I'll do is I'll do 31 and then I'll do this, so I can save the most tedious for last. Draw a triangle within the unit circle that corresponds to negative 765 degrees, then clearly state the value of all 6 trigonometric functions with respect to negative 765. So here's what we need to do. You only have 3 trig functions you know, sine, cosine, tangent. That's it. So you would state all 3. So the first problem, negative 765, is not a good angle. So I'm going to keep adding 360 until it becomes normal, and that's going to be 315 degrees. That's what it's equal to. 315 degrees would be over here in quadrant 4. It doesn't really matter to me if you draw the unit circle. It's implied anyway. You drop your line. This creates a right triangle. Remember, this is 315 and this is 360. So if you subtract, you'll find that this in here is a 45 degree angle. This must be a 45, 45, 90 right triangle. The side lengths are 1, radical 2 over 2. And because this is down, it's negative radical 2 over 2. So here's all you need to be able to do. Sine is the height. So sine of negative 765 degrees is equal to negative radical 2 over 2. Cosine of negative 765 degrees is the base, so that's equal to positive radical 2 over 2. And tangent of negative 765 degrees, tangent is equal to sine over cos. So that's equal to negative radical 2 over 2 over positive radical 2 over 2. If you've been paying attention in algebra, you know that when I divide something by itself, it becomes 1. So the real answer here is just negative 1. You can keep change flip. If I keep change flip, I'll get negative rad 2 over 2, change it to multiplication, and flip it into 2 over positive rad 2. The 2's cancel out, the rad 2's cancel out, and all you're left with is a negative sign and an implied 1, because everything else is gone. Same thing. So that would be your answer, sine, cos, and tan. All right, last one, the tedious one. Question number 30. Identify the solution set of the following system of 3 equations. Now, I'm just going to rewrite these so I can pull them over to loose leaf. Negative 2x minus 2y plus 2z is equal to negative 4. Negative 2x plus y plus z equals 15. And 6x plus 4y minus 2z equals negative 4. Alright, so the methodology is worth covering, so I don't mind doing it. Our goal is to find what values of x, y, and z will make these true. All 3 of them. So here's what we need to do. What we need to do is we need to pick a letter that we wouldn't mind canceling out. Just pick one. It doesn't matter which one. For the sake of this, what I'm going to do is I'm going to use z. Okay, so pick a letter, and you're going to cancel it out. Here's how you're going to cancel it out. And I'll color code these to make this a little easier on you, because I know that it seems like a lot goes on in the paper with these. Okay. Alright. So here's what I'm going to do. I'm going to take 2 of the equations, and I'm going to line them up so that I can cancel out z. I'm going to choose the red one, and I'm going to choose the blue one. I chose these 2 because the z's have the same number on them, but the opposite sign. That's really perfect. Because what I can do now is I can just add these 2 equations. 2z plus negative 2z cancels out. Negative 2x plus 6x is 4x. Negative 2y plus 4y is positive 2y. And negative 4 plus negative 4 is negative 8. And this is a big moment because we've gotten rid of one of the variables. I'm going to circle that. Now I'm going to cancel z again. You have to pick the same letter. Oh, but wait, these numbers don't match up. So here's what I'm going to do. I'm going to take this green equation, and I'm going to make this into a 2z by distributing a 2 into it. When I do that, what I'm going to get is I'm going to get negative 4x plus 2y plus 2z is equal to 30. And then I'll just bring the blue one along for the ride again. We'll use addition again to cancel out these z's, because they have opposite signs, so we can just add them. Negative 4x plus 6x is 2x. 2y plus 4y is 6y. 2z plus negative 2z cancels out. And 30 plus negative 4 is 26. So this is my second equation. What I'm going to do now is I'm going to take both of these and line them up and try to cancel out another letter. So if I look at these, 4x plus 2y equals negative 8, and 2x plus 6y equals 26, I get to pick which letter I want to get rid of. I'm going to take this one and multiply it by a negative 2. What that's going to get me is negative 4x minus 12y is equal to negative 52. Now the reason for that is that I can now take this original equation, unmodified, and the one that I just modified, and I can line them up, and I can cancel out those x's. When I do that, I add these together, the x's cancel, 2y plus negative 12y is negative 10y, and negative 8 plus negative 52 is going to be negative 60. Divide both sides by negative 10, and you get that y is equal to 6. That's the first of our solutions, so that's really big. We got a letter, okay? So now that we got that letter, we want to plug back in. To which equation? To one of these circled guys. I want to plug back into one of those. So I'm going to pick the one on the left. I'm going to pick this guy. I'm going to say 4x plus 2y is equal to negative 8. But y in this case is 6. So 4x plus 12 equals negative 8. Minus 12 minus 12. 4x is equal to negative 20. Divide both sides by 4. And I get that x is equal to negative 5. Now that I have y and x, I can plug them into one of the original equations. So pick whichever one just looks the easiest, I guess the middle one. And we're going to plug in there. So let's see if I can get this by itself and get rid of the lines again. What I'll do is I'll just copy it. So we'll take this equation from the top, copy and paste it, to down here, and I'll plug in. So I get negative 2x, which is negative 5, plus y, which is 6, plus z equals 15. This is 10 plus 6 plus z equals 15. 16 plus z equals 15. Minus 16 on both sides. And you're going to get that z is equal to negative 1. And the last thing you want to do with these is put them in the right order, x, y, z. So negative 5, 6, and negative 1. That would be how I want to write my final answer, x, y, z. Okay, so that would be the answer, and that is the end of the review sheet. I hope this has all been very helpful. See you guys tomorrow.